Bismillah ar-Rahman ar-Rahim. Good morning, everybody. Inshallah, our lesson today in organic chemistry, chapter 19. I'll talk about alkanes, alkenes, and alcohol. In this period, I'll talk about alkanes and alkenes. Okay. In the last period, I explained to you that no need to use a board today. I prepare the lesson and I'll send a copy from my preparation to you, inshallah. Okay. In this lesson, I'll talk about, as I said to you, alkanes, alkenes, and alcohols. Today, I'll talk about alkanes and alkenes. We are in chapter 19, page 156. Okay. In the last period, I explained to you that we have what we call hydrocarbons. What does it mean by hydrocarbons? Hydrocarbons are compounds that contain carbon and hydrogen only. Hydrocarbons are compounds that contain carbon and hydrogen only. In the last period, I said to you, in case of organic chemistry, all organic compounds contain carbon. There is no organic compound without carbon. Okay? And I said that hydrocarbons are compounds contain carbon and hydrogen. And we divided these hydrocarbon into two categories. I said to you they are three categories, but in your subject you have only two. We have alkane and alkene. According to what? According to the kind of covalent bonding between carbon and carbon atom. So if we have single bonding between carbon and carbon atom, so it will be alkane. And this alkane with a general formula CnH2n plus 2. And I said to you N is the number of carbon. Today we have to know an important thing. In the last period I explained to you that we have a secret code for the number of carbons that are meth, eth, prop, but, and so on. And if you know the number of carbon, multiply it by 2 and add 2 to it to get the number of hydrogen. Today we have to know a very important information about alkane, which is alkanes are saturated hydrocarbons. Saturated hydrocarbons. What does it mean by saturated hydrocarbons? They carry the maximum number of hydrogen according to the number of carbon we have. Again, saturated means that the compound carry number of hydrogen atoms, maximum number of hydrogen atoms according to the number of carbon we have. How? Like this. If I talk about methane, so I have one carbon. This one carbon contains 4 arms, so these 4 arms will carry hydrogen. Saturated cannot be able to carry more than these 4 hydrogens. If we have 2 carbons, it will be ethane, and as you see, each one carry 3 carbons and enter in a covalent bonding between carbon and carbon. So both carbons I have carry the maximum amount of hydrogen atoms. So saturated, we call alkanes are saturated hydrocarbons because they contain the maximum possible number of hydrogen atoms for a given number of carbon. Okay, let's talk about the physical properties of alkane. You know or you don't know, I'm sorry, this is a new information for you. The physical properties of alkane that the first 4 alkanes, that's to say الميثان, ethane, propane, butane, okay, the first 4 alkane are gases in nature. are gases in nature at room temperature. At room temperature. From pentane 5 carbon, it will change into liquid at room temperature. طيب, we have solid state in alkane, yes, but this solid state appear when I reach to carbon number 17. Okay, and in this case carbon number 17. So what is the number of hydrogen multiplied by 2 equal 34 plus 2 equal 36. Okay, so the physical properties of alkanes, that the first 4 alkanes are gases at room temperature. From number 5 till number 17 are liquid, and the solid state start from alkanes with carbon number 17. Okay, I'm still talking about alkane, and you have to know this property. As the molecules get bigger, as the molecule gets bigger, increase in number of carbon atoms. As the molecule gets bigger, the intermolecular force between them increase. Between them, which them? Molecules. Okay, as the molecules get bigger, the intermolecular forces between them gets bigger or increase. So when the intermolecular force increase, I need more energy to put or to break the attraction force between these molecules. So here, as the molecules get bigger, we have 2 facts. The intermolecular force between these molecules increase, and more energy has to be put into break the attraction force between one molecule and other. Okay, we said alkanes contain carbon-carbon single bond, carbon-carbon single bonds. Okay, according to the number of covalent bonding, is it single carbon-carbon covalent bonding or double carbon-carbon covalent bonding? We have an important term. What is this term? This term is homologous series. Homologous series. Okay, what does it mean by homologous series? Homologous series is a family of compounds with similar properties, similar chemical properties. Family of compounds with the same chemical properties. Why with the same chemical properties? Because they have similar bonding. Maybe all of them single carbon-carbon single bonding or carbon-carbon double bonding. Okay, so according to the homologous series, we have alkane and alkene. Alkane are family of compounds with similar properties because they have similar bonding, and alkenes are also another family of compounds with similar properties because they have similar bonding. Okay, you have to know this definition, the definition of this term very well. Important. Homologous series. Okay, we said that alkanes are a homologous series family of compounds contain single carbon-carbon bonding. What are the chemical properties of alkanes? We will take only 2 chemical reactions which are very easy and important reactions. The first one is combustion, and you know that combustion is a synonym for burning, a synonym for oxidation. So when alkane burn in enough amount of oxygen, all of them will give carbon dioxide and water. Important information. Combustion of alkanes in enough amount of oxygen, important enough amount of oxygen, will give carbon dioxide and water. If I burn methane, ethane, propane, butane, yes. And what is the difference? The difference in the balancing of the equation. Sorry. So the first chemical reaction of alkanes, combustion in enough amount of oxygen. And the second chemical reaction called substitution reaction. Substitution reaction. Okay? Substitution reaction is a reaction between alkane and bromine. Reaction with bromine called substitution reaction. As you see, methane plus bromine produce methyl bromide and hydrogen bromide. Why we call it substitution reaction? Let's see. I'll explain it here on the board. I have methane, C, H4. Add to it bromine. Okay, what happened? Br2. Substitution. How substitution? Look, remove one hydrogen and put Br. Remove another hydrogen and put Br. Okay, so we have bromine plus methane produce just one. I'm sorry, it is not easy to me to take a photo from this board. Okay, attention, I have methane, CH4, and this carbon with 4 arms, hydrogen. Okay, I'll substitute one of them by putting Br, just one Br, like this. We can put it up, down, on the right, on the left, no problem. And what's left from the Br2? We have another Br with the hydrogen removed from here. Here make HBr. Okay, so again, the second reaction, which is an important reaction between alkanes, and I give you example methane with bromine, is a substitution reaction. Important to know the name of the reaction. I'll ask about it. So in case of alkanes, we have only 2 chemical reactions. The first one, combustion, and produce carbon dioxide and water. The second one with bromine, and we call it substitution reaction. Okay, this all informations I want from you to know about alkane. What about alkene? Alkene is also hydrocarbon, so consists of or contains only hydrogen and carbon. But the difference between alkane and alkene, the suffix ene, with the carbon-carbon double bonding. Carbon-carbon double bonding. And the formula of alkene is CnH2n only. We call alkene are unsaturated hydrocarbon. Alkane saturated, but alkene unsaturated hydrocarbon. Why? Because we have double bond. We can split this double bonding and carry other hydrogen or other thing more than hydrogen. But here takes the maximum number of hydrogen according to the number of carbon given. Here the presence of double bond means they don't contain as many hydrogen atoms as the corresponding alkane. When I talk about physical properties of alkenes, I have the same properties of alkanes. That first 4 members are gases, then liquid, and finally solid with the highest number of carbon. When I talk about chemical reaction of alkenes, I have also combustion. What is the difference between this combustion and that one? In case of alkanes, like this, in case of alkanes, I said combustion. There is no difference because both of them produce or give carbon dioxide and water. So combustion of any hydrocarbon produce whatever alkane or alkene, carbon dioxide and hydrogen and water. Okay, what is the difference in writing equations? The balancing of equation, a number of oxygen atoms, a number of carbon atoms and so on. Okay, so the first chemical reaction for alkenes is also combustion and produce carbon dioxide and water. Here alkene is another homologous series. What we said about homologous series, family, okay, of compounds with the same chemical properties according to the kind of bonding. So we have a homologous series for alkanes and another homologous series for alkenes. طيب, you will say, teacher, you said combustion here like combustion there. Yes, but reaction with bromine, in case of alkanes, we call it substitution reaction. And I explained to you how substitution. But here, reaction with bromine, we call it addition reaction. Addition reaction. Okay? Why? Because here, look, this is ethene plus bromine. What happened? Split the double bonding between carbon and carbon and add both bromine both bromine atoms here, like this. So I have C double bonding and 1, 2, 3, 4 hydrogen, ethene plus bromine. Just add the bromine to this ethene. Split the bond so I can add the bromine and the product is only one product, like this. The last thing in our period today, how I can test presence of carbon-carbon double bonding. How I can know that the compound I have is alkene, contain carbon-carbon double bonding. In test, we use bromine water. This bromine water is orange in color. When I add it to a solution contain alkane, that's to say single carbon-carbon single bonding, the color will be brown. And in case of alkene, carbon-carbon double bonding, the color, which is orange, fade or decolorized and change into colorless. So to test presence of carbon double bonding, we use bromine water, which is orange in color, with alkene, give me colorless. And where you can find this experiment in your book, here. In page 159. In page 159. Case of alkane, it will change into brown, like this. And in case of alkene double bonding, it will be colorless, like this. Okay. Okay. The last thing I want to know that I said to you, in case of presence of enough amount of oxygen, there is combustion or burning. I said enough amount of oxygen. And also in case of alkenes with enough amount of oxygen, give carbon dioxide and water. But if the amount of oxygen is not enough, what happens? We have what we call incomplete combustion. What does it mean by incomplete combustion? In case of incomplete combustion, the hydrocarbon burns in not sufficient, not enough amount of oxygen. So instead of producing carbon dioxide, it will produce carbon monoxide. Carbon monoxide. What are the properties of carbon monoxide? It is colorless, odorless gas, and very poisonous, very poisonous. My question will be, why incomplete combustion is dangerous? Because the carbon monoxide gas produced during two insufficient oxygen is gas, colorless, odorless, and very poisonous. Why very poisonous? Because it combines, carbon monoxide combines twice faster than oxygen with the hemoglobin, the hemoglobin of the blood. Carbon monoxide combine with this hemoglobin and prevent the hemoglobin to carry oxygen. So there is no enough amount of oxygen reach to the body cells, and you know that the body cells need to make cell respiration. So there is no energy produced and make illness and in some cases die. Okay, because there is no enough amount of oxygen reach to the cells, body cells. So incomplete combustion occur due to insufficient or not enough amount of oxygen during burning of hydrocarbon. This produces carbon monoxide, which is colorless, odorless gas and very poisonous. Why very poisonous? Because it combines with the hemoglobin of the blood and make what we call carboxyhemoglobin, as you took in biology. This carboxyhemoglobin, or the combination between carbon monoxide and hemoglobin, prevent hemoglobin to carry oxygen to the body cells. So not enough amount of oxygen reach to the cell, make ill or even die. Okay, so our lesson today, I start chapter 19, which is alkanes. Alkenes, I didn't talk about alcohol today. We took this page. This page explained to you that we have the first four alkanes are gases, then liquid, and I said to you we reached to the solid with carbon number 17. What does it mean by incomplete combustion? Burning in not sufficient amount of oxygen, and what is the harmful effect producing carbon monoxide. Okay, and I talk about alkenes, properties of alkenes, whatever physical properties, reaction or chemical reactions of alkenes. In case of alkanes, we said we have substitutional reaction with bromine, but in case of alkenes, we call it additional reaction. How I can test alkenes, how I can test the presence of carbon-carbon double bonding? By bromine water. It will give me brown color with alkane, carbon-carbon single bond, and colorless with carbon-carbon double bonding alkenes. Okay, I'll make a copy from this summary for you. I'll send it with the video to you, inshallah. Okay, this is our period today. Thank you. Best wishes.